Derivatives. Calculus is the study of rates of change and has applications in all the natural sciences, as well as in engineering, finance, economics, and medicine. In mathematics, we can use graphs to illustrate the rate at which things grow or decay. Graph A shows the growth of bacteria in a culture over a short interval of time. So here we have graph A. The x-axis represents time and the y-axis represents the number of bacteria. The graph indicates that the rate of growth is relatively small at the beginning but increases as time goes by. So the rate of growth is small at the beginning, so we have a gentle slope at the beginning, and then it increases as time goes by, so the slope gets much steeper. Calculus enables us to find the growth rate at any instant in time. The growth rate at a particular time, t, is the slope of the tangent to the graph at t. And this can be seen in graph B. So in graph B, we still have the pink curve, which we saw in graph A, but now we also have drawn in a straight blue line, which is a tangent to the curve. A tangent is a line that touches a curve at one point, and it touches it at t. The slope of the tangent to a curve, y equals f of x, at any point x, f of x, which is the same as xy, on the curve is denoted by dy dx or f prime x. So dy dx is read as dy dx, and it means to differentiate y with respect to x. And f dash x is read as f prime of x. So this little dash here, or apostrophe as we're used to in English, we pronounce as prime. One can differentiate with respect to any variable. So for example, ds dt means to differentiate s with respect to t. dA dr means to differentiate a with respect to r. And the rule for differentiation is bring the power down in front and reduce the power by 1. So we'll see a few examples of this now in a minute. So again, the rule is bring the power down in front, reduce the power by 1. So if y is equal to ax squared, where x is an element of the real number set and a is any constant, then dy dx is going to be 2ax to the power 1. So the 2 we bring down in front of the a, so we get 2a, and the power we reduce by 1, so 2 minus 1 is 1, so we get 2ax to the power 1. And this is also written as f prime x is equal to 2ax. If y is equal to ax to the power 3, again where x is an element of the real number set and a is any constant, then dy dx is equal to 3ax squared, because what we did was we brought the 3 down in front of the a and reduced the power by 1. 3 take away 1 is 2. So we get 3ax squared, also written as f prime x is equal to 3ax squared. If y is equal to a, where a is any constant, then dy dx is equal to 0. Because if we want to differentiate y with respect to x and we don't have an x, we just get 0. If y is equal to f of x plus g of x, then dy dx is equal to df dx plus dg dx. So what that really means is we differentiate both functions on their own and then we add the resultant answers. So we differentiate and then we add them. So here's our formula. If y is equal to x to the power of n, then dy dx is equal to nxn minus 1. So the n comes down in front and we reduce the power by 1. So it's on page 25 of our tables. But it would be better just to learn off the method. Bring the power down in front, reduce the power by 1. So differentiate the following with respect to x. So remember the rule for differentiation is bring the power down in front, reduce the power by 1. So if f of x is equal to x squared, then f prime x, or the derivative of x, is equal to 2x. So what we do is we bring the 2 down in front, and we reduce the power by 1. So we brought the 2 down in front and we reduced the power by 1, and 2 take away 1 is 1, which equals 2x to the power of 1, which is just 2x. So let's have a look at another example. So if f of x is equal to x cubed, f prime x is equal to 3x cubed minus 1. So we bring the 3 down in front and we reduce the power by 1, and 3 take away 1 is 2. So we get 3x squared. So if f of x is equal to x cubed, then the derivative of f of x, or f prime x, is equal to 3x squared. Okay, let's have a look at another one. Let's say f of x is equal to 7x to the power of 4. Then f prime x, or the derivative, is equal to 4 times 7x to the power of 4 minus 1. So we had 7x to the power of 4. We bring the power down in front, which is 4, and we reduce the power by 1, 4 minus 1. Now when you bring the power down in front, you're multiplying. So it becomes 4 multiplied by 7, which is 28. And the power is 4 minus 1, which is 3. So you get 28x cubed. Let's say we have f of x equals minus 2x to the power of 5. So we end up with 5 times minus 2x to the power of 5 minus 1. So we had minus 2x to the power of 5. We bring the 5 down in front. So it becomes 5 multiplied by minus 2x. And we reduce the power by 1, 5 minus 1. So we get minus 10x to the power of 4. Because 5 multiplied by minus 2 is minus 10. A minus by plus is a minus. And 5 take away 1 is 4. Okay, let's have a look at another example. So again, we want to differentiate the following with respect to x. And the rule is bring down the power in front, reduce the power by 1. So if f of x is equal to 2x, the derivative, f prime x, is equal to 2. So let's have a look at why that is. Well, 2x is really 2x to the power of 1. And the rule is we bring down the power in front and we reduce the power by 1. So bringing the power down in front, bringing the 1 down, it becomes 1 multiplied by 2x, which is 2x. And reducing the power by 1, 1 minus 1 is 0. So we get 2x to the power of 0. Now x to the power of 0 is equal to 1. Anything to the power of 0 is equal to 1. So this becomes 2 multiplied by 1, since the 2 was stuck onto the x to the power of 0, and anything stuck together in maths means multiply. So 2x to the power of 0 is really 2 multiplied by 1, and 2 multiplied by 1 is 2. So if f of x is equal to 2x, then the derivative of f of x, f prime x, is equal to 2. Now thankfully you don't have to write this out every time. It's just important that you understand where we got the 2 from. So if f of x is equal to 3x, then all we have to do is cross off the x to get the derivative. So f prime x is equal to 3. So if you ever want the derivative of an x to the power of 1, because x on its own is really to the power of 1, you just cross off the x. So if our function is 3x, then our derivative is 3. So if our function is minus 4x, then our derivative is minus 4. If our function is 100x, then our derivative is 100. So to get the derivative of any x on its own, so if it's x to the power of 1 technically, all we do is cross off the x. So again, we're going to differentiate the following with respect to x. This is really important, with respect to x. So again, the rule is we bring the power down in front, reduce the power by 1. So if our function f of x is equal to 4, and there is no x, well then we cannot differentiate with respect to x. There is no x. So our slope or our derivative is just going to be 0. So f prime x will be 0. So basically, if you have no x, then to differentiate it, you just cross it off or you write equal to 0. So if our function is equal to 5, our derivative is equal to 0. If our function is equal to minus 2, our derivative is equal to 0. If our function is equal to 20, in this case, instead of f of x, I'm calling it y, which basically means the same thing. F of x and y are the same thing. Then our derivative, dy dx, is equal to 0. So f prime x and dy dx are the same thing. So basically, if you have a function and there is no x value in it, then you either cross it off or you say it's equal to 0 if you want the derivative. So again, we're going to differentiate the following with respect to x. The rule is bring the power down in front, reduce the power by 1. So if f of x is equal to x squared minus 2x plus 5, f prime x is equal to 2x minus 2. So what we do here is we differentiate each individual term. So to differentiate x squared, we bring the power down in front and we reduce the power by 1. So we get 2x to the power 2 minus 1, which is 2x to the power 1, which is just 2x. So that's where the 2x comes from. To differentiate minus 2x is really minus 2x to the power 1. So again, we bring the power down in front and we reduce the power by 1. So you get 1 multiplied by minus 2x to the power 1 minus 1, which gives us minus 2x to the power 0, because 1 take away 1 is 0, and 1 multiplied by minus 2 is minus 2. And x to the power 0 is 1. Anything to the power 0 is 1, and minus 2 times 1 is minus 2. So that's where the minus 2 comes from. And then to differentiate 5 with respect to x, well, there is no x, so we can just cross it off, or we can let it be 0. So the derivative of x squared minus 2x plus 5 is 2x minus 2. Now for the minus 2x, we could have just crossed off the x and straight away got the minus 2. You don't need to write all of this out, but I'm just showing you where it comes from. So let's try another one. So if y is equal to x cubed plus 4x squared minus 5x plus 8, then dy dx, the derivative, is equal to 3x cubed to the power 3 minus 1. So we bring the 3 down in front, reduce the power by 1, which gives us 3x squared. Then to differentiate plus 4x squared, we bring the power down in front, so the 2 comes down in front, so it becomes 2 multiplied by 4x to the power 2 minus 1, because we reduce the power by 1. And 2 times 4 is 8, so we get plus 8x, and 2 minus 1 is 1. So you can say plus 8x to the power 1, or just plus 8x, which is the same thing. Now, to differentiate minus 5x, all we have to do is cross off the x, and we get minus 5. And to differentiate plus 8 with respect to x, there is no x, so we just cross off the 8. So the derivative of y equals x cubed plus 4x squared minus 5x plus 8 is 3x squared plus 8x minus 5. Let's try another example. Differentiate the following with respect to x. Bring the power down in front, reduce the power by 1. Remember, this is the rule. So if f of x is equal to x cubed plus 4x squared, then f prime x is equal to 3x squared plus 8x. So we bring the power down in front, reduce the power by 1. So that's where the 3x squared comes from. And now to differentiate plus 4x squared, we bring the power down in front, reduce the power by 1. So we get 2 times 4x, which is plus 8x. And then 2 minus 1 is 1. So we get 8x to the power 1, which is just 8x. So the derivative of f of x equals x cubed plus 4x squared is 3x squared plus 8x. Okay, let's have a look at another example where there's an extra step added in. If y is equal to x squared minus 3x plus 8, find dy dx, the derivative, when x is equal to minus 1. So we do the same steps. We bring the power down in front, reduce the power by 1. So let's start off with x squared. Well, if we bring the power down in front, the 2 comes down in front, we get a 2 in front of the x. And reducing the power by 1, reducing the 2 by 1, 2 minus 1 is 1. So we get 2x to the power 1, which is just 2x. So we brought the power down in front, so that's why the 2 is in front of the x, and we reduce the power by 1. 2 minus 1 is 1, so you get x to the power 1, which is just the same thing as x. And then to differentiate minus 3x, well, since there's no power, we can just cross off the x. So we end up with minus 3. And to differentiate plus 8 with respect to x, there is no x, so we can't differentiate it. So technically we get 0, but we just don't write anything down. So if y is equal to x squared minus 3x plus 8, then dy dx is equal to 2x minus 3. So now we have the derivative. We have dy dx, which is the slope of the equation. So x squared plus 3 minus 3x plus 8 is a curve, is a U-shaped graph. That's an x squared graph. And the derivative, the slope of the curve, is a straight line. So we have worked out the slope for the tangent of the curve. Now we're specifically interested when x is equal to minus 1. So the point on the x-axis at which x is equal to minus 1. So in order to work that out, we take our derivative, 2x minus 3, and we swap the x for minus 1, but we put brackets around it, because the 2 and the x are stuck together, and anything stuck together in maths means multiply. So we're going to have 2 multiplied by minus 1. And 2 multiplied by minus 1 is minus 2, and minus 2 minus 3 is minus 5. So dy dx is equal to minus 5. So the slope of the tangent at that point, if that point is x is equal to minus 1, is minus 5. And another way of asking this question is to find f prime of minus 1. They can phrase it this way as well. So instead of saying finding dy dx when x is equal to minus 1, they can ask you to find f prime of minus 1. So f prime here, this little apostrophe symbol, means you differentiate, and then you substitute x as minus 1 into your derivative. So we swapped the x in 2x minus 3 for minus 1. So if f of x is equal to x cubed plus 4x squared, and we want to find f prime minus 1, so the f prime means the derivative, so we bring the power down in front, reduce the power by 1. So the 3 comes down in front, and we reduce the power by 1. 3 take away 1 is 2. So we get 3x squared for the derivative of x cubed. And then for plus 4x squared, we bring the power down in front, so the 2 comes down in front. So it becomes 2 multiplied by 4. And we reduce the power by 1. 2 take away 1 is 1. And 2 times 4 is 8. And x to the power 1 is the same thing as just x. So the derivative of our function is 3x squared plus 8x. And since we wanted f prime minus 1, we already have the derivative, and now we swap any x value for minus 1. So we swap this x value for minus 1 with brackets. Make sure you have brackets or it'll work out wrong. And we swap this x for minus 1. Again, we have to have brackets. So minus 1 squared is 1, and 3 times 1 is just 3. And 8 times minus 1 is minus 8. And 3 minus 8 is minus 5. So f prime minus 1, or the derivative of f of x when x is equal to minus 1, is minus 5.